Erlang actually, this is in English they call it the Poisson distribution. Poisson distribution. This is more or less normal distribution, but it's with the less population. Which means that you want to have the normal distribution, you should have some kind of a big observation or big population to see the normal behavior of the value. For example, when we observe the height of the people, okay, and then we know the minimum height should be around 1 meter third 1.3 meter, and the highest people 2.4, and then in the middle we have around 1 point. Let me put it into calculation. 1.3 plus 2.4 divided by 2. So you have the mean value is 1.85 meter at the normal height of human. And if you have the population of, for example, million observations, and then you can see this distribution, this normal distribution. But so, for example, you just observe in the small scale of 1,000 people, and this is more represent the distribution in the Erlang or Poisson distribution. This means the high possibility not happen in the mean value, but in the low value. Okay, so this is Poisson, the distribution. Do you have any questions so far? Questions?
No, I have no.
Okay, so if you have no questions, and then I think we can move to some important before we close this first lecture. So, sorry, let me share my screen again. Share screen, entire screen, share. Okay. Then before that we close this today lecture, so I want to differentiate the difference between the continuous and discrete event simulation. So we have simulation model. Simulation model will show you the behavior of the system over time. And what is the behavior of the system? The behavior of the system is can represent through the attributes. Okay. Sorry guys, so I need to go to open the door. A bit. Hello, can you hear me?
Yes, Mr.
Hello. Okay, so again, so simulation model, we present, we show the model show the behavior of the system over time. So what is the behavior of the system? The behavior of system is a set of all of the value or the we call it the attributes in Siemens simulation, Siemens plant simulation. The other software they call it properties. It means the value of attribute of all of the attributes of a model represent stages or represent the behavior of the system. For example, where we modeling a factory, all of the value of all objects that compose the factory will be system behavior. Okay, and this value is defined in a certain point in time. So we call it discrete event simulation. So for example, this is where we can find all of the value of attributes or properties of all objects in a certain time. And this is the change of those value, and somewhere in between it remain the same. So it means that in at this time, as for example here is at 0, we have this type of the system value or system behavior, and during the time from 0 to 9, for example, the value remain the same. Okay, and at this time there is a certain event happen that change the value of the system, and this is a new value, new stages, or new behavior of the system. Okay, and everything between these 2 points it remain to the previous one. Okay, and the continuous simulation, it means that the value, the attribute is traceable to, at all time. For example, the location of a car, location, yeah, location, the location of AGV in the factory, location of the packet travel along the conveyor system, or we can say the temperature in the welding process, and so on. Okay, this is continuous simulation, and of course we have the combine of these two type of simulation, because we have the factory where we integrate also AGV within discrete event system. For example, machine where the product go in, go out during the processing of the part inside the machine. We didn't know what it changes. We just know the state of the product at the beginning of the machine, and at the end of the working time or processing time, we have the material is changing, for example, from raw material to semi-finished product. And what happened in between, it remain the same. Okay, it means that this is a black box. We don't know what is happened inside. We just care. Okay, the first event is enter to the machine as the raw material. After processing time 1 minute, the workpiece become a semi-finished product and ready for the next step. Okay, and then to call to transportation for this workpiece from one station to another station, we use AGV. AGV go along or freely in the workshop floor. This means that the location is changing over time continuously. Okay, we have the this is where we have the combined simulation. Okay, here is a example of continuous simulation. Yeah, so here is just uh, again what I just explained to you, where you have the activity inside the machine 8. Okay, so this is event when you start the process, and this is where you end the process, and this is a duration. And for example, we have the workpiece have the attribute of x, y, z with the value, and then after that the value of x, y, z is updated, but during this time the value of x, y, or z is remain the same. Okay, and here is the one. This is not every. This is the working principle of the discrete event simulation. Follow the activity scanning. Okay, there is a lot of principle that have you build up the discrete event simulation. Here is just one, not not for every discrete event simulation. Different simulation, different software, they have the different working principle. And here is just one example about discrete event simulation, how it works. Okay, so for example, here is the start of simulation. They will initiate or deinitialize all of the event and put it to a list. We call it event list. Okay, with the external variable, and then they will evaluate for the next event. Okay, and after the next event happen, they will refresh the status of all of the object. They update the statistic, and then they step into the next event. Okay, and for every end of these three process, they will ask the same questions. Simulation finish. The simulation finish, normally they will have two conditions: no new event, or the observation duration. It means that the time that you specify. So end the simulation after 8 hours, for example. Okay, again, simulation is finished. Normally we will add two scenario. The first one, no new event in the event list. The second one is the simulation time reached to the defined simulation time. Okay, if no, then we'll jump to the next event. Okay, and keep doing the update of the status of all of the projects, update the statistic, and then generate the next event. Okay, and then if it's end of the simulation, they will create the report, and then it's end. Okay, just like what we have also a station and a rain. Okay, so the first will initialize the simulation. The new MU is created. Okay, and the next event is MU go in here. Okay, the next event is MU go out. The next event is MU go in the thing and be destroyed. Okay, and there is a list of all of that event. Okay, and they just execute this list. Okay, and add to the list the new event for each refresh here. So it means for each time that you step to an event, you will update what there is a new event For sure, if you have here event of new mu is created at the source, and then of course new react. So the next event will be go in the machine. Okay, right here. The next event is go in the machine because go in the machine have the processing time. The future event will be mu go out of the machine, and of course when it go out it will go to the sink. So another future event is go to the rain and so on. Okay, until they have no new event or they reach to the simulation time. Okay, so this is a working principle of the simulation model. Uh, okay, so and this kind of the event list is here. Okay, you can open the event controller in the plant simulation. Click on the list here, and you will see all of the event with the time of that event and the description of that event, the object, and the parameter. Okay, and then the last thing that I want to talk with you is about the simulation and animation. Okay, so what is the difference between simulation and animation?
Let me take a look.
So yeah,
Sorry, are you sharing your screen?
yes, I
Yeah.
okay. So sorry.
Um,
So I have it. Okay, now sharing the screen again. Sharing. Can you see my screen
yeah.
with the thing spare? Thing
Yes. Is
spare
there a difference
spare.
between
There is
simulation?
the need. Yes. So here you can see here they have two uh, video here. The first is about the working principle of the pump. Okay, and the second, the one on your right hand side, is traffic conjunction. Okay, and then you can see both of them are animation. Yeah, at first you think that okay, the one on the left hand side is animation, and the one on the right hand side is simulation, because they have different traffic and so on. But if you just showing someone some videos, so it's purely animation, not simulation. Remember when we talk about the simulation, the very important point is the possibility to answer a what if questions, or can have the power of what if analysis. What does it mean? It means that if you have the chance to somehow input the, for example, the time of the red line or the time of the green line on the for the traffic conjunction, and then it's become a simulation. If there is no chance or no possibility to change the parameter to have different outputs, so it's poor animation. And or again, for the left hand side, when you have the demonstration of the working principle of a pump, so if for example you can uh, increase the speed of the wheels of the rollers, and then you can have the different output rate, and then it becomes a simulation. Otherwise it's just animation. Okay, is it clear? So simulation uh, can or cannot have the animation. Some simulation just give you the result without any type of animation. not 2D animation, 3D animation. When you input the data, you press enter and then it gives you the result. So this is also called simulation without any animation. Okay. Do you have any question? Otherwise, so this is end of the lecture. Okay.
Sorry, Mr. Đức. Uh,
Yep.
my Moodle site I cannot access to my Moodle site. Like I cannot access into the lecture slide or any slide anymore. Yeah. Can
It
you
means
check?
that you
Yeah.
it means that
Like,
you already have the access to it, and now it's no longer available.
yes, yes. I have already access to it on Saturday, and right now it's not available. Can you check for me?
Okay.
Yes. Yes.
Okay. Then how about the others? You have the same
Yeah,
issue,
Yeah,
or
me
I
too.
also got the solution like you.
okay. Then I will, or someone already have in my side. Maybe. Me. Okay. So it's nothing from my side. I didn't change the setting of my. Let's check my setting. Hmm. User permission. Yeah. Nothing. Hmm. Okay, it's weird. I didn't change any setting inside the Moodle. You have all of permission to access, to post, to do anything in the Moodle. The user is not reached the limit. The storage still have enough space. Hmm. Why? What happened? Did you try? No, no, you cannot. Okay, so let me, for example, mm, okay. So what should I do? Should I allow you to create a new one, or should I delete all of the user and then you register again? So let delete all of the user and then you can. So maybe Mr. Tao first. So Mr. Tao here, they said that you accept 1 minute ago. Hello, Mr. Tao. Are you there?
Uh, yes, I try to accept again, and it said that what, sorry, let me.
Can you share my screen to me, please, so I can see what happened from your side?
Okay, okay, let uh, here.
Enrollment is disabled or okay, so it's about enrollment. So let me check about the enrollment. Login enrollment in hmm. Why they said enrollment, shell enrollment, student enrollment disabled or inactive? Active. Okay, so I will figure it out later. Uh, because we have not much time for today, but I still want to um, correct some exercises for you if you have trouble with. So because we don't have much time left, so do you have any specific exercise that you don't understand, uh, and then you really need me to go through it uh, at least one time? So maybe you can tell me now. And then after the today lecture, I will check again the Moodle to make sure that it's working properly. The worst case that I will delete all of the user, and then you need to um, sign up for the Moodle again. Okay, this is a worst case. In any case, so I will uh, email to the student about my action, that what I did in the Moodle setting, and guide you what you should do, revisit it, or create the new account on Moodle. Okay, so now what is the exercise that you think that I need to go through? So according to the last activities, so every one of you should be finished now until exercise 14. So do you have some doubt about any exercise until exercise 14, or even uh, any exercise? No. So if no, so I will do exercise 21.
Did you hear me?
Yeah, sure. Yeah.
Could you quickly go through exercise number 10 and 11, the two related to
Okay.
the basic resource and the human resource problem? Because I don't think we have already worked through these two, right?
Okay. So then now I will go to exercise number 10. Okay. Share screen. Share screen. My screen. Share. Then now I will do exercise number 10 and number 11. Okay, find new 2D. Okay, so I have event and controller. I'll go to resources here, the tab resources, or you can find here in the last library where we have the worker pool, the food path, and then we create the material flow here, one source, one buffer, one machine, another buffer, machine not yet, and then one rain. Okay, holding the control to connect them together. Okay, and then this is the material flow, so I can fill the fill. So this is a material flow. This is not. It's 9. So maybe this one. Okay, this is material flow. Okay, it means workpiece here, go here, go to the station, go to buffer, and then go to the rent. So this is material flow. And then here we have another flow. It's the flow of workers. So normally we call it resources flow. Okay, and this is a worker pool. It act like a source. Okay, work path, just the some kind of animation to have a animation about the worker working along to the machine, along the work path to the machine. And then so the workplace, sorry, I need to go back to home, click on the workplace, and then place it here. Okay, with the control T I can rotate the workplace. So, okay, in the way that this workplace is for this station. I also connect the worker pool to the footpath. Sorry, worker pool to footpath, and from footpath to workplace. Okay, and then of course, yeah, changing the name of it here, pressing F2, turning machine. Okay, and I need to have the supervisor. Supervisor. No, this is broker. Broker. You can change the name supervisor to broker. Normally, I will let it at broker, but anyway, change this to supervisor, so you can know so how to set up it. So about the resources flow, so the worker pool go here along the footpath, go to the workplace. The supervisor, this one, this object is a broker, and this is to connect the material flow to the uh, resources flow. Okay, you need this one. Okay, to let the system know when workpiece go here, go here, go here, and this turning machine need to have the worker to activate the machine. Otherwise, this will wait in here until they have workers. And then double click here to the worker pool. You click here to indicate that you want to change this table. And this is where you specify the amount of the worker that you want to create, the number of shift, the speed. Normally I will type here 1.5, the efficiency, and additional service. So it can be this service is for about picking up the transportation of the material and so on. But here I just keep it simply like this, and yet you see the broker here is not the broker anymore because I already changed the name of it. So I need to choose the correct one. And then what I need to do is I need to tell the workplace, okay, which station that you control. Here I will control the turning machine. And then I need to specify here in the importer tab, okay, about which broker, but here I already changed the name it into supervisor. Okay, so again, supervisor is the guy that do the connecting data, transfer the data from this type of flow to this material flow. You have the worker as the MU in the resources flow from worker pool, working path, footpath to workplace, and you have the MU as a part or entity go from source to buffer to station to buffer one and to rank. Okay, this to flow needs a guy called broker. This one, okay, to exchange the data. And here I create a broker. Okay, change the name is supervisor. Normally you don't need to change the name here. Just put the broker here, and you don't need to set up any thing inside for now. Okay, and then yeah, that's it. This is all that you need to do. You can also rather than click here to connect, you can simply drag and drop this to here. Yeah, and then now you can run the simulation and see this is waiting. See, you have the yellow, which means that even it's a cry in the machine because no one here. Okay, this machine does not start. And then we have the worker. After you have the full, yeah, and then it's become green, and then this is the simulation model. Okay, any questions? And then this is one workers, and then we extend our model into we have two worker, two places. Okay, exercise 11. Sorry, you have questions? Okay, then I will continue with exercise 11. Again, you just need to modeling two different type of flow. The first flow is the one that you already knew, the material flow, and another one, the one that for this exercise is resources flow. And here is the workers. Okay, and connect them together by using the broker. Okay, and the setup of that is not difficult. You just need to specify the information which workstation belong to which station. Okay, and then you have the resource flow. This is worker pool. It means where the worker is created. And then you have food path. Okay, here to here. Okay, and another food path here to here. You can put them together here, and also again connect. For sorry, I need first the workplace. Okay, you can simply drag and drop the workplace, the station to the workplace like this, and it's out. So it's no which workstation. For example, here I changing the name of it. Turning machine. Okay, and then you see they become some kind of transparent, not gray. So it means it's not yet connected. So I just need drag and drop this to here, and then it's become a array workplace. Okay, here is the same. I changing it into milling machine, and then this become transparent. So I drag and drop, so it's already connect. This footpath is a bit too long, and of course in the exercise they specify the length of it, but here it's just for short, so I just assume that this is the correct length of the footpath. Okay, here to here. Okay, that's it. Then the number of worker you specify here. Remember, you need to click here. Okay, so it become a dash within the yellow background. So it means that you are modify this table. So let's do the speed of 1.5, and the amount is 1 for the moment. So, and then this red here, it means that you are not yet have a broker. So just simply create it without changing the name of it, so you don't have to set up here again the supervisor here, and also here. What you just need to do is active this one, and also active this one, and that's it. And of course you have many other options, for example, but so get the job order in the work pool only. So when you check in this box, so it means that where you have the job in the station, the worker go back to the worker pool and then work again to that workstation. Okay, if you declick this one, it means that it can, okay, from here go to here and go to milling machine, and then where there is a workpiece in the turning machine, it can go from milling machine to the turning machine without come back to the worker pool and then go here. Okay, so it's very simple. You can read and then you understand. If you read, you don't understand, what you can do is you can point your pointer here and then press F1. This will have more work for you to read. We have the new work order for performing a service at the station in the worker pool only. Clear the checkbox to assign the new order anywhere. For example, while a worker walks along the footpath. And the sim talk, it means that when you programming, you can write the get job order in worker pool only equal to true. Yeah, so that's it. This is more worker can work remotely. This means that they can work from here to here, and then if this is not clear, you just point out here. Sorry, this is belong to the first one, that F1, and then they can do the definition. Okay, this means that you workplace fee. This means that they can find the free workplace and then enter to the free workplace. Okay, and also here in the I don't know, this is workplace. Here you have the capacity. You can have the option of the worker stay here after the completing job. Normally, if you have they click this one, if we go back to the worker pool, okay, here we want they to stay. Okay, so this is some option that you can choose for more close to your reality or more close to your system in the reality. Okay, now I think that's everything that I need to set up. Okay, and then we can run the simulation step by step. And you can see that, yeah, so I have one worker, so that's the reason why the material flow is stopped. Now cannot run smoothly because I have only one worker and he have to go switch the workplace from turning machine to milling machine. Okay, and if I have two workers, and of course they don't need to go but rather stay as the station. Okay, so they just stay at the workstation, and then you see that normally if you have two workers, and then it's better that to not need the resources flow anymore. It means that you have always the worker at the machine. It means just reduce the level of detail, okay, and think that the machine and the workers as one unit, okay. They run the machine all the time. But if you have one workers that use or that activate the machine manually, okay, and he work two or more machine, and it's been that in this case it's better to modify or to modeling the worker behavior through the resources flow. Okay, is it clear?
Hi, Mr. Duck. I have a question.
Yeah.
So from this simulation, can we show the total time that the tool is idling or the total time the worker is idling due to some kind of ancillary time?
Okay, so you want to have the statistics of that. So normally I didn't do it because the idling of the workers or the working time it's corresponding to the machine here. Sorry. So if the machine is working, it means that they need the workers, and this is they waiting. So it means that the workers go with someone else, and if you can track the this through the machine. But I think there is a possibility to check this type of statistic, and how you can do it. You can click on the workplace, press F8, and looking for the statistic that you want to have. So statistic, where is the statistics number? No. So maybe worker. So attribute and method. And here. Let me here. Okay, show the attribute and method. And then let's check the speed. So attribute and method. And what is the statistic of it? So you can see here that this is the start and end time. So it could be the one that we're looking for, or the operational time. If this is something that you think it is, so you can press F1, and then it will. So this is return the total time that take up for working process of the exporter decided by the path, and because the path of us is the workers, so this means this is a working time of the worker. So here the path. When you open any window, the dot resources dot worker, and this worker is number 2. So this is the path or the address of the object. Okay, for example, you double click here, and this will indicate so which object that we are looking into. So we are looking into the turning machine. Okay, and turning machine belong to model 1. The model 1 belong to the folder models, and the models belong to the root. The dot here is mean the root, is mean that the very top here. Okay.
Yes, okay, thank you.
You're welcome.
Mr. Duke, I have another question.
Yeah, let me stop my sharing. Yes.
I tried to follow your instruction for this exercise, but somehow the worker in my exercise doesn't move. Both of them. They keep staying at the worker pool.
Can you show me your model, please?
Hang on. Can you see my screen?
Yeah, I can see it.
So this is the current worker pool setup. Creation table, I have 2 workers.
Yeah, so sorry. Can you hold me for 1 minute? So guys, if you have no more questions, so this is, you can leave the meeting. So I have nothing new about the lecture, and I think that we can stop at exercise number 10 and 11. nothing new for today. If you still have questions, you can stay in the meeting. If not, you can leave. And yeah, so I wish you a nice evening, and see you tomorrow, where I have one more lecture. And I think that tomorrow I will shorten my lecture and then more focus on these exercises, because I think that it helps you a lot to build up your skill, and then you can work with your projects better. And if you still have questions, you can stay all the while, and then you can leave. And for those who are leaving, I wish you a nice evening, and see you tomorrow. Yep.
Yeah, see you. Yeah,
Okay. Bye bye.
yeah, good night.
Then yep, Mr. Sơn,
Yep.
you can continue.
So for the first one is the settings for the worker pool. Right now I'm having D setting. Creation table I have 2 workers with a speed up 2 and efficiency of 90%. And I also check for the get job orders in the pools only. The travel mode is to work along the footpaths, and rocker would be taken from this one. First one, the 2 station.
Okay,
I
maybe you can let the simulation model run step by step, not this one,
oh,
the one on
sorry.
the last one, yeah, on the last in a row. Yes, please click it, and then you have to observe, and then you can see the you are not yet activate in the turning machine. Can you help me double click on the turning machine? Double click, double click
Um,
to
double click
open.
in this one.
Double click on the turning machine.
The workplace, right? Or the
No, the turning machine. No, no, not the turning workplace. The turning machine. Yes.
Is it the simulation mode first? Reset.
Yeah. The reset, and then double click on the turning machine to open the turning machine window.
right. It's on. But I think I'm only sharing one window. So let me share again.
Yeah, sure.
See it now?
Yep, I see it now. And then go to tab importer, the one in orange. Yeah, activate it. Yes, and then that's it. Apply. Okay, and then the same with the importer. It means that now you active the connection between this machine to the broker, and the broker to the worker pool, and now it's working.
I see. Thank you, Mr. Duke.
Okay, you're welcome. And then how about the order? Do you have any problems about this exercise?
Yes, I have problem with this one. May I share my screen?
Yeah, sure.
Okay. Yeah, can you see my screen now?
Yep, I can see it.
Yeah.
Let me read the error message. There is no path for the models exercises 11 human to and beaming the worker is not allowed. Okay, you can yes, stop the motion. Yes. Okay, so now they says that the workers that you raise is not in. So uh, can you press the reset button,
Yeah.
and then can you run the simulation model step by step? Okay.
It stopped right here. Right here.
Okay, beaming is mean that the workers cannot jump or teleport to the workplace. Okay, so you can say yes, a- and then can you have me double click on the worker pool? And then okay, I get it. So can you close it? And then can you have me delete the connector between the worker pool and the footpath? Yes, delete this one, and then delete also between the turning workplace and milling workplace. It means that cannot beam. It means that the worker cannot jump into the workplace. It means the problem that you have here is the connector. So maybe the connector that you use is belong to the material flow, not the resources. Can you go to the resources? Yeah, use this connector. So maybe sometimes that you click on the material flow and this is not correct. So this is the connector. Yeah, use this one. Yes. And now you can run the simulation again. It still happen. And then maybe it's can you make your footpath a little bit so you can make a space between two footpaths, making some space so to make sure that they are connected to check. Okay, so now if they are not connected, this is a problem. A footpath, you should also connect the footpath to the footpath one. Yes. Okay, so I think now it's work. Okay, you know the problem now. So it means that
Yeah.
there is no connector, so they cannot jump between the footpath.
Yeah.
Okay,
Thank you so much.
the footpath is an object, and to indicate that two object is connected, it means we need connector.
Yeah. Thank you.
You're welcome. Then how about the orders? You still have the questions? If not, you can leave the meeting now, and then we can see tomorrow again.
Dạ, em cảm ơn thầy.
Không có chi.
Thầy ơi, ngày mai thì em có số cái chuyện về cá nhân đó thầy, thì cả em với lại Ly sẽ không có tham gia lớp được thì nhưng mà tụi em vẫn muốn gọi là có
Đúng rồi, quên. Đáng lẽ hôm nay phải record lại. Có đứa
dạ,
gặp thầy
đúng rồi
quên
thầy.
mất.
Đúng rồi thầy. Dạ. Tụi em đang tính hỏi thầy là ví dụ mai thầy có thể record lại được không ạ? Tại có một số cái bài tập thì thật sự
Phải có đứa nào nhắc. Có phải là đứa nào nhắc quên nhiều khi phải.
Dạ.
Ủa cái này Google có record được không? Hay là chỉ record từ bên Zoom hết? Quên nữa. Thôi được rồi, để thầy finger out cái này ấy rồi mai thầy record lại. Quên nữa.
Dạ vâng. Dạ. Vậy em cảm ơn thầy ạ. Mai thì tụi em không vô lớp được nên em xin phép thầy trước ạ. Dạ.
Ok.
Dạ. Em cảm ơn thầy.
Không có chi.
Dạ, em chào thầy.
Em chào thầy.
Ok, bye bye. Mr. Phạm Uy Nhật Trường, are you there? Mr. Phạm Uy Nhật Trường, are you there? Hello. Hello. Mr. Nhật. Trương Phạm Uy Nhật, are you there? So if no, I will leave the meeting.